Okay, so in the beginning of class today, we talked about section 6.6 using proportionality theorems. So our proportionality theorem said that if a line is parallel to one side of a triangle, intersects the other two sides, then it divides the two sides proportionally. So here we're given that AC is parallel to DE. Okay, so by our triangle proportionality theorem, we know that this parallel line DE cuts the sides of my triangle proportionally. Okay, so now we can use our theorem to figure out this problem. So let's fill everything in that we know. We know that AB, okay, this entire length is going to be 24. We know that BD is 16. We know that AC is 26. EB is 12. We want to find out what CE is and DE. Okay, so now we're going to start using our properties. So our triangle proportionality theorem tells us that since AC is parallel to DE, then EB is proportional to CE, and DB is going to be similar to AD. Okay, so let's fill in all of our information here. We're going to be solving for X. So EB equals 12, CE equals X, DB equals 24 minus 16. Okay, we got to find what this piece is. Okay, so 24 minus 16 is going to give us 8. So DB is 16 and AD is 8. To solve for X, you're going to cross multiply. You get 16X equals, you're going to get 12 times 8. Okay, go through and solve for X, and X is going to equal 6. Alright, now we have to go through and we have to solve for Y. So I found that X is 6, right? So I'm now going to set up my proportions with my big triangle and my small triangle again. So I know that the base, if you look at it that way, or these two parallel lines, right, they're proportional, so I'm going to have Y over 26. So I took my small triangle and I put it on top of my large triangle, so I need to stay consistent. So now I'm going to look at this side is going to be 18, okay, and then we'll look at this piece of my smaller triangle. So it's going to be proportional to my small side is going to be 12, and my big triangle side is going to be 18. Cross multiply, okay, you get 18y equals 12 times 26. When you go through and you solve for y, you're going to get y equals 17.3. Okay, now I want you on your own to go and try to apply the same thing to the next problem. Okay, so this problem was very similar to the one before it, except now we have a little bit of algebra going on with our variables. So here's the answer. Okay, if you are not able to come up with this and you cannot figure it out using this key, you need to come see me during directed study or during class. Okay, for this next problem, we weren't given anything about our parallel lines like we were in the first two. We're given our similarity statement. So from our similarity statement, as you guys know, we can set up our proportions. So I know that BA is going to be proportional to BD. I know that AD is going to be proportional to DC, and BD is going to be proportional to BC. Okay, we have these two separate. So I got that from looking at my similarity statement and then just pulling out what I know from that. Okay, so I'm not going to go too much into that. So if I start filling in these values, I know that BA, okay, is 18. BD is 24. AD is X. DC is 40. BD is 24. And BC is Y. Okay, so I'm going to need to use this ratio, or my scale factor, for both finding X and Y. So if I solve for my X first, okay, I got 18 over 24 is equal to X over 40. I need to cross multiply, which is going to give me 40 times 18 equals 24X. When you solve for X, you should get X equals 30. Okay, now let's solve for Y. So I'm going to use this ratio of 18 over 24 again. Okay, so if my two triangles are similar, all my sides should have this same scale factor. That's why I can use it for both. Okay, so that was back in 6.5. If we're going to say that our two triangles are similar, then all their sides are going to be proportional. They're going to have the same scale factor or ratio. Okay, so I'm going to set that equal to 24y, cross multiply again. 24 times 24 equals 18y. Solve for y, and y is going to equal 32. Okay, so this picture has a lot going on, but don't let it scare you. So we're giving that ST is parallel to RU. So now we're going to be using this triangle proportionality theorem again. Okay, so you know that if my lines are parallel, then my alternate interior angles are going to be congruent. We are also told that ST is 56. Oops. UR is 80. WS, this piece, is 28. WT, this little piece, is 42. WU is going to be X, and WR is going to be Y. And we got to find out if what triangle URW is similar to. So, okay, so triangle URW, okay, URW is this little triangle in here. So we're going to want to make that similar to STW. Okay, so we're going to want to say that this triangle is similar to this triangle. And the way that I pull that out is because I want to be using these two parallel lines, okay? And I got these alternate interior angles that are congruent. Okay, so I'm using this by angle. Okay, then I'm going to say that these two triangles are similar. So, UR is going to be proportional to ST. Those are my two parallel sides. Okay, SW, well, actually, let's look at RW first. Okay, we're using the bigger triangle. So let's look at side RW. RW is going to be proportional to TW. Okay, and UW, our last side, is going to be proportional to SW. Okay, make sure you're paying attention to where you're putting your letters. Okay, order does matter here. Okay, so U and S are both congruent, so that's why they're the first ones as we write it. So UR is 80, ST is 56, RW is Y, TW is 42, UW is X, and SW is 28. Okay, so same deal. 80 over 56 is going to be equal to Y over 42. Cross multiply. 56y is going to equal 80 times 42. Solve for y, and y is going to equal 60. Okay, same deal with x. We're going to say 80 over 56 is going to equal x over 28. Cross multiply. So you're going to have 56x equals 80 times 28. Solve for x. X is going to equal 40. Okay, if I were you, I would be pausing the video and I would be trying this algebra on my own to make sure that I know how to do this. Alright, so here are some more examples of our shadow word problems like we talked about in the beginning of class as well. So a fire hydrant is 2.5 feet tall and casts a shadow 5 feet long. Okay? How tall is this street lamp if it casts a shadow of 26 feet long? So these both create a triangle at a 90-degree angle. Okay, we can say that these two triangles are similar because they're both of our triangles are going to cast a shadow at the same angle because our sun is going to be hit both of them at the same angle. Okay, so by angle, we can say that these triangles are similar. Okay, so if we want to talk about our proportions for our shadows, okay, for the fire hydrant, our shadow is 5 feet. For the lamp, the shadow of our street lamp, that is going to cast a shadow of 26 feet. Okay, our height of our fire hydrant is 2.5 feet, and we got to figure out what the height is for our street lamp. So we're just setting up a proportion. So we're going to cross multiply, and you're going to get 5x equals 26 times 2.5, and the height of your street lamp is going to be 13 feet. Make sure you don't forget your units, okay? You will get a half a point off if you forget your units, okay? Another way you could have looked at this, if this is going to confuse you, just pause the video and keep going. We compared the proportions of our shadows to our heights. You could have also said, okay, well, my fire hydrant, you could have compared the fire hydrant to your street lamp. So my fire hydrant is 2.5 feet tall, and it casts a shadow of 5 feet. Okay, that's going to be equal to the height of your lamp and the shadow that it casts. Okay, so I got height over shadow and height over shadow. If you cross multiply and solve for x, you should get 13 feet for x as well. All right, here's another example. In this figure, triangle DBA, okay, this triangle DBA is similar to ECA. So the small triangle and the big triangle are similar, okay? We know that. They share this common angle, reflexive, and any triangle that's inscribed inside the other triangle, they're going to be similar. Okay, so AB corresponds to AC, and BD corresponds to CE. So I can set up a proportion here. I know that AB is therefore proportional, we're told here, to AC, and BD is proportional or corresponds to CE. Okay, and I want to find the distance across the lake. So I want to find this. So I want to find this distance across my lake, CE. So this is going to be my unknown. So AB equals 320 meters. AC equals 320 plus 162, which is 482. BD is 40 meters. And I don't know what CE is, so I'm going to cross multiply. So you're left with 320 meters x equals 482 times 40. When you solve for x, you should get x is approximately 60.25 meters. Now I use this approximately symbol because I didn't get a defined decimal points at 2 decimal places. So it's approximately 6.25 meters. Okay, what you should do now is you should finish the last two problems. I will bring up the answer keys. You should do them on your own and check to make sure you're getting it right. If you have a question, you should be coming to me and asking the question.